Good afternoon, we are team number 15, composed by Daniela Villegas, Maria Villegas, and Jorge Zavala. Today we are going to present our pedestrian system design.
The agenda for today consists of the topics Introduction, System Design, Design Improvements, and Test Plan.
For the introduction, for this project section report, the team has come with the implementation of a pedestrian warning system located inside of a car. We decided to design a PWS that will have the ability to state by visual and audio in the direction from where the pedestrian is coming from in order to achieve a more efficient, safely effective, and warn the driver faster. The system design, our system will be implemented on the radio display of the vehicle. It will be a 6-inch screen that will be connected simultaneously to a camera in the back of the car and another in the front. On the left side of the screen, there's a small icon of a car with 8 squares surrounding it. And on the right side, the recording of a specific camera will be displayed. The camera and the 4 squares at the front of the car will be activated when the car is moving forward, and when the car moves backwards, the 4 squares on the back will be activated in conjunction with the camera from the back. Each of the squares represents a dangerous area from where a pedestrian can approach the car. When a pedestrian or an object is within 5 feet to the areas from where the sensors are, the PWS will display a beep approximately 100 decibels to alert the driver. For every foot that the pedestrian gets closer to the car, the beep will repeat faster. Similarly, when the pedestrian is within a foot away from the car, the warning sound will be one solid beep at the same 100 decibel level. The square on the screen representing the area where the pedestrian is located will turn red to alert the driver visually from what direction the pedestrian is coming from. If the pedestrian walks across the front of the car from right to the left side, the squares in the front of the car will light up accordingly to the area the pedestrian is approaching, and vice versa. For example, in the photo, the display of the PWS is represented as if the pedestrian was walking from the right. The square from the right corner turned red. Another feature our design implement is a square at the bottom. It will display checker surroundings as a warning message. Furthermore, at the bottom as well, on the left corner of the screen, there will be another message. It will display either front or back according to which camera is activated.
One of the improvements the team decided to implement is a multidirectional camera. By implementing this type of camera in the system, it reduces the chances of missing pedestrian, small objects, or giving false alarms. In the case that there is a pedestrian or a small object on the driveway, the multidirectional camera will adjust and display it. This change will help to improve the detection of pedestrians. The multidirectional camera will monitor from all angles, making sure it is in fact a pedestrian, and then alert the driver. Another improvement is to change the warning message that is displayed at the bottom to the center of the screen. This is shown on the photo. The message will be the same as the previously designed, but it will be displayed in the center of the screen and it will be blinking to get the driver's attention. Since it was decided to move the warning message, there will be now another message displayed at the bottom of the screen. As you can see in the photo, the message will be either right front, center front, left front, right back, center back, or left back, to further alert the driver in what direction the pedestrian is crossing.
In order to start with the test, we will start with the front side of the car. First, we will park the car and place a person in one of the spaces that are covered by a square to see if the beep will go off based on the distance that the pedestrian is from the car. The camera records the front view, and if the squares in the screen light up accordingly to the location of the person. On the other hand, the camera should be visually tested by placing cones that are small enough for the driver not to see. If there is a traffic cone in the front of the car and the driver can see from the driver's seat through the window, as soon as the driver puts the car in drive, the beep will go off and the driver will be able to see what is in the way by looking at the camera. Once the front test is finished, we will do the exact same test for the back side of the car. That concludes our presentation. Thank you.